Hey guys, welcome to Simplifysics. This video is the first in the series on the unit of mechanics. So let us start by considering motion and its cause. In translational motion, a body changes its position continuously, whereas in rotational motion, a body spins about its axis. Translational motion is caused due to a force, whereas rotational motion is caused due to a quantity called torque. So this video is an introduction to torque. So what is torque? In layman's terms, a torque is nothing but a twisting force that causes rotational motion. So in order to understand torque, let us first understand how a rotation is caused. So let's say here's a plank. To cause rotation, we must have a point that is fixed, a point that will serve as the axis. So this point is called the pivot. And then we must have a force that causes the plank to rotate. So in order to cause rotation, we will require a pivot and then a force that is acting some distance away from the pivot. So what does this torque depend upon? Here there are two planks and they will be acted upon by two forces of different magnitudes. Let's see what happens. We find that the torque is greater with a 20 Newton force, and therefore we can say that torque depends on the magnitude of force. Now we've got these two planks and we will have two forces of equal magnitude acting on the planks but at different distances from the pivot. Let's again see what happens. We find that the torque is greater where the distance between the pivot and the force is greater. So what that means is that torque depends upon the distance between the force and pivot. But there's also one more consideration that you need to take. Here we have three planks and there are three forces F1, F2 and F3 acting on these three planks. These three forces are of equal magnitude and apparently they are at the same distance from the pivot. However, our experience will say that the first plank will have the maximum torque, the second plank will have lesser torque, and the third plank will have no torque. Why is that so? In the first plank, the distance between the pivot and the line of force of F1 is D1, which is greater than D2, which is the distance between the pivot and the line of force of F2. In the third case, this distance is 0 as F3 acts along the length of the plank and the line of F3 passes through the pivot. So here the torque in the first plank is greatest, followed by the second plank, and in the third plank the torque is 0. So what we can say is that torque depends upon not just the distance but the perpendicular distance between the force and the pivot. So that means torque is the product of force and perpendicular distance from the pivot. Tau equals to F into the perpendicular distance d. So tau is the symbol for torque, it's a Greek letter, and the units of torque are Newton meter, dyne centimeter, kgf meter and gram force centimeter. Now torques can be clockwise as well as anti-clockwise. Here we have an example of two forces that cause clockwise moments. So by convention, clockwise moments are always considered to be negative. And conversely, here are two forces that cause anti-clockwise moments. So by convention, anti-clockwise moments are always considered positive. So how do we use all of this to solve a problem? Here's a plank. It is pivoted near about the center, and here are the forces acting on the plank. These forces are at different distances from the plank. The clockwise moment is caused by 16 Newton, whereas the anti-clockwise moment is caused by 8 Newton, 10 Newton and 3 Newton. So let's first calculate the clockwise moment. The clockwise moment is 16 Newton into 6 meters because the 16 Newton force is 6 meters away from the pivot. Hence, the sum of clockwise moments is negative 96 Newton meters. The anti-clockwise moments come out to be 87 Newton meters, and therefore the net torque is equal to minus 9 Newton meter. Now so far we know that to cause rotation we require a pivot and a force. However, we must also understand that there's a force that causes the plank to be fixed at the pivot. It means that torque is always caused by two forces. Let's look at a situation where a torque is caused by two forces. Here's a plank. So what happens when these two forces act on the plank? The plank rotates. So when two forces are equal in magnitude, opposite in direction, and parallel to each other, they are said to have constituted a couple. Now the distance between the two forces is called the arm of the couple, and the torque of the couple is equal to force into arm of the couple. Here we may consider any of the forces, not both of them. And now the summary of this video. Rotational motion is caused due to torque or moment of a force. The product of force and perpendicular distance from pivot is called torque. Clockwise moments are always negative, whereas anti-clockwise moments are always positive. Torque is always caused due to the presence of two forces, and two equal, opposite and parallel forces constitute a couple of moments. So that's all in this video. In the next video, we will be looking at equilibrium and principle of moments.